These are the notes on two-step molar conversions. You'll want to have a calculator and a periodic table handy. In the last video, we did one-step molar conversions, where we were just going between moles and particles or between moles and grams. And we could go either direction on these. Now, if we want to go between particles and grams, we're going to have to do two conversions, and we're going to have to convert to moles first. And so with these two-step molar conversions, key is always converting to moles first because that's our common unit relating particles and grams. So the process follows the exact same steps that we've done before. We're going to first do a conversion to moles. So if we're going grams to moles, and then after that we could go moles to particles, or we could go the other way, particles to moles and then moles to grams. And so with that setup, we're going to have our given value is going to be first. And I always write it as a fraction over 1. And so that's the value your problem is giving you. And then we're going to have our first step conversion factor where we're converting to moles. So moles will be in the top, getting rid of whatever our given unit was. And then our second conversion factor is going to get rid of moles. And then we want to, in the top is going to be the unit that we want, or kind of our ending point with that. And so that's going to be our second step, is that second conversion. Once we have that set up, then we'll be able to do the math based on the values that are in those conversion factors. And so if we have or want grams, then we are going to use that molar mass in grams is equal to a mole. Finding the molar mass, we use our periodic table and add up all of the elements in that compound in whatever ratios they are in. And then if we have or want particles, we're using that 6.022 times 10 to the 23rd. Particles equals 1 mole is our conversion factor. So these are our two conversion factors we've talked about previously, and we're going to use those. It's just that we're going to have two conversion factors in our setup, 1, 2, instead of just 1. And if this chart is helpful for you, we have the conversion factors between where you're going from particles to moles. Our conversion factor is here. Either moles can go on the top and particles on the bottom with that 6.022, or we can have our particles on the top and our 1 mole on the bottom, depending on what direction we're going between those units. Same thing with our molar mass conversion down there. All right, let's go through a couple of examples. How many particles are in 4.5 grams of calcium hydroxide? With these two-step conversions, because we are going to be starting at, we're going to be going between particles and grams, we're always going to need that molar mass. And so we take calcium hydroxide, we've got that neutral compound here for us. So let's find the molar mass for calcium hydroxide. I have 1 calcium. And so that calcium has a mass of 40 from my periodic table. I'm referencing that calcium right there, 40.08, rounding to the nearest whole. And I have 1 of those, so that's going to be 40. Oxygen, I have 1 oxygen in my OH, but I have 2 OH groups. And so I'm going to have 2 of those. Oxygen has a mass of 16. So 16 times 2, because we have 2 oxygens, so that's 32. And then my hydrogens have a mass of 1 from my periodic table, that 1.008. And I have 2 oxygens, so then that's a mass of 2. So we're going to get a mass of 74 grams per mole is our molar mass for that calcium hydroxide. All right, now let's set up our conversion. So we put our starting value is 4.5 grams of calcium hydroxide. And that goes in the top of, or is my starting value. I always just put that over 1. The one doesn't have a units, it's just so that when I have fractions in the next two conversion factors, it's helping me stay organized. Now we're going grams to moles in this one. And so as we look at that going grams to moles, my conversion factor is going to be this. I am starting at grams, so that means that my grams, my molar mass is going to go in the bottom of my fraction, so I can cancel it. The 1 mole is going to go in the top of my fraction or my conversion factor. So we're going to have 1 mole on the top over our grams of our calcium hydroxide, and that value is our molar mass, so 74 grams in 1 mole of calcium hydroxide. All right, now if we were to end here, looking at my units, the grams of CaOH2 cancel. So we now have units of moles. So now I'm going moles to particles. I want to end up at particles. So whatever I want to end up with is going to go in the top of my conversion factor. I want to get rid of moles. So 1 mole is going to go in the bottom of my conversion factor. And now I can set that up. And our 6.022 for particles doesn't change depending or with our different elements. So 1 mole on the bottom and 6.022 times 10 to the 23rd particles of CaOH2 on the top. And we can see now moles cancel, so we're left with a particle unit. Now what's left is for us to go and do our math. Each teacher does this a little different. How I like to go and do it is I like to multiply all of the numbers in the numerator first. 4.5 times 1 times 6.022 times 10 to the 23rd, 4.5. And I get 2.7099 times 10 to the 24th. And then I'm going to divide that by, and I'm going to multiply everything in my denominator. 1 times 74 times 1, so that's 74. And I'm going to divide that top number by the bottom number. And I get 3.662, and this number keeps going, times 10 to the 22nd. And let's just round that to 2 decimal places. So 3.66 times 10 to the 22, and we need to add on our units, particles of CaOH2. So if we had 4.5 grams of calcium hydroxide, that's going to be equivalent to 3.66 times 10 to the 22 particles of that substance. All right, let's do another example. This one now, how many grams, so we're looking for grams, are in 3.4 times 10 to the 34th particles of sodium fluoride. So that's my given. So now we're going to go the other direction. We're starting with particles and we're ending with grams. And I know I'm going to need, anytime I have grams, I'm going to need my molar mass. So I need to find my chemical formula. Sodium has a +1 charge. Fluorine has a -1 charge. This could be, or this is an ionic compound, so we're using our charges, and we're going to have 1 sodium and 1 fluorine in NaF. So finding our molar mass, sodium has a mass of 23, and I have 1 sodium. Fluorine has a mass of 19, and I have 1 fluorine. And I can add those together. So my molar mass is 42 grams per mole is the molar mass of sodium fluoride. And I got my sodium value from rounding that 22.9 and my fluorine from that 19. So using your periodic table. All right, now let's go and set this up. So we have our given value first, 3.4 times 10 to the 34th particles of NaF. And I put that just as a fraction over 1, just so I can stay organized, because I'm going to need now 2 more conversion factors, And so it's going to help me so I have something in the numerator and denominator for all of those, even though there's no unit on that one in the bottom there. So I want to get rid of particles. So because I have particles on the top, I'm going to have particles in the bottom of my first conversion factor. And looking back at our chart, now we're going the other way. So we're starting with particles going to moles, meaning that whatever I want to get rid of is going to go in the bottom. Whatever I want is going to go in the top. So I want 1 mole, so that's going to go in the top for that conversion factor. So we've got our 1 mole of NaF in the top, my 6.022 times 10 to the 23rd in the bottom. I ran out of space a little bit. That allows for my particle units to cancel. And then now I want to get rid of moles. So I have moles in the top here. I want to get rid of moles, so moles are going to go in the bottom. And if we're going moles to grams, 1 mole of sodium fluoride is the molar mass. So we're going to put our molar mass, grams of sodium fluoride. Well, we found that 42, that's going to go as our value in the top. You can see those moles units are on the top and the bottom, so they cancel, meaning we're only left with our grams unit, which is what we want, how many grams. And I can go ahead and do my math. Your teacher might do this a little different. Another way you can do this is just treat each of these as a fraction when you type them into your calculator. So we would type in 3.4 times 10 to the 34th divided by 1 with parentheses, and then we go times 1 divided by 6.022 times 10 to the 23rd. With this, we have to make sure we're either using our scientific notation button, or you also have to put parentheses around that bottom number, and then times 42 over 1. If you have Miss Andreessen, I believe that's how she teaches you to put that into your calculator. So if you like that way, you can, just writing each of those as fractions and multiplying each together. Otherwise, I will multiply all my numbers in my numerator. So 3.4 times 10 to the 34th times 1 times 42. And that's 1.428 times 10 to the 36. And then I'm going to divide that by all of the numbers in the denominator multiplied together. The nice thing is it's 1 times that 6.022 times 10 to the 23rd times 1, so it's just that 6.022 number. And then we're going to divide those two. You have to be careful with order of operations when we're using that scientific notation. I suggest using that scientific notation or that E button in your calculator, or using those parentheses. And make sure you're trying this in your calculator, actually going through and doing that division so that you know what, how to go about doing this work. So we've got this here. So then when we divide, I got 2.37, and then that number keeps going. So I'm going to just round to 2 decimal places, and then times 10 to the 12th grams of sodium fluoride. We don't always, or we don't often have scientific notation in our for our grams units, but because this was a 10 to the 34th to start, it's a huge number, and we're only dividing by 10 to the 23rd. So it makes sense that we still have an exponent for that scientific notation in our answer. All right, we have 2 more problems here. I'm going to go through, I'm going to pause. I'm going to find the molar mass and the chemical formula. I'll talk through the process. Feel free to pause and go through the whole problem if you are feeling comfortable and want to try one on your own. All right, so magnesium cyanide is that MgCN2, parentheses around that CN. And then for molar mass, I got 76 grams per mole. Feel free to check your work. All right, so we've done one like this before. So how many grams? Now we're looking for grams are in particles of this many particles of magnesium cyanide. So this is our given. This is going to have the exact same setup as our previous problem, except for we're going to have a different molar mass and we're going to have a different starting value. So once we get the hang of it, you'll see we kind of have two different setups, and the things that are changing are our starting value and our molar mass. So we're given 2.9 times 10 to the 24th particles of magnesium cyanide. And then we're going to have two conversion factors. Looking at our chart, I thought I put it in here again. It's okay. Looking at our chart now, again, we're getting rid of particles, so then that's going to go on the bottom so that the particle units cancel. We want to get to moles first, so that's going to go on the top. Keep referencing that chart if it's helpful for you. So we have 6.022 times 10 to the 23rd particles of magnesium cyanide on the bottom, and that's equal to 1 mole, which is going to go on the top. Particles cancel. Now we need to get rid of those moles, so we can get rid of moles by putting moles on the bottom. And 1 mole is equal to that molar mass, so we're going to use that 76 grams on the top, which is that molar mass we found. My mole units cancel. I'm going to be left with grams, so now I can go ahead and do my math. I'm going to multiply 2.9 times 10 to the 24th times 76. And I got 2.204 times 10 to the 26. And then I'm going to divide that by, and I'm going to multiply everything on the bottom together, 6.022 times 10 to the 23rd. And then I'm going to divide that top purple number by the bottom number. And I got 365.991. And that number kind of keeps going in my calculator. So if we round to the nearest, if we round to 2 decimal places like we have before, we're going to keep that 365.99. And then I need to put my units on my answer, units being grams of magnesium cyanide. That's our answer. All right, there's one last problem on here. I'm going to go ahead and do the problem. Feel free to pause the video and then come back to see the answer. All right, so with this one, how many particles are in 7.5 grams of oxygen? This one has that same setup as the very first problem we did, going from grams to particles. And we need to stop in the middle and go grams to moles and then moles to particles, but we can do all of that calculation at once. Oxygen is diatomic. On our periodic table, if you remember back, those diatomic elements only exist in compounds or in pairs. So either in a compound with something else or attached to its twin. So anytime we see nitrogen, it's going to be N2, oxygen O2, fluorine F2, chlorine Cl2, bromine Br2, or iodine I2, and then hydrogen also H2. And so with that one, my formula then is O2, so the molar mass, I'm going to need 2 times oxygen, so that molar mass is 32 grams per mole. And then with my setup, I have my given value is that 7.5 grams of oxygen, writing it over 1 so it's a fraction. And then my first conversion factor is going to cancel grams, leaving us with moles. My second conversion factor is going to cancel moles, leaving us with particles, which is what the problem asked for. And then I can go do my math. My yellow number on the top is all of my top numbers multiplied together. My blue number on the bottom is all of my bottom numbers, the denominator numbers multiplied together. And then I'm going to divide the top by the bottom. And I got 1.41. I rounded that. My calculator had more digits, so I just rounded to 2 digits for that leading number in our scientific notation, times 10 to the 23rd, and then we need a unit, particles of, what's our chemical, of oxygen. Hopefully that made sense. Reach out to your teacher if you have questions. There is a 2-step molar conversion worksheet for practice, and there are answers provided. There's also a 2-step molar conversion check-in for you to practice. Take a look at our rubric on scale, proportion, and quantity, design, and model to get an idea of where you're at. Good luck.